Hello everyone, so welcome back to my YouTube channel, and today we have a very most important topic, that is OSPF area concept. So basically what is an OSPF area? So it is a logical grouping of what? Routers that shares the same link state information. Basically in OSPF the link state information will be shared when there will be neighborship. Okay, and in that case the OSPF area creates the logical grouping of what? The routers on the basis of what? Link state information. That is means the link state information will be shared limited to the areas. That is means same area routers will only share the information, will reduce the congestion. So areas are used to reduce the amount of routing information. That is means less routing information will be shared when there will be any update. So that is means the load will be reduced. That needs to be processed by each router. Okay, thereby optimizing the network performance. So we can also optimize the performance of network into areas. So OSPF limit the propagation of routing updates. Well, let's discuss about why need the OSPF area. So, dear all, let us assume we have 13 routers in our network. 1, 2, 3, and 13 routers are there, in which two routers like R2 and R3 are the old configuration routers that can hold up to what? 10 routers that can hold the database up to what? 10 routers only. So R2 and R3, these two routers are old configuration router, can only hold the routing updates up to what? 10 routers. After that, the hopes will be unreachable. So in this case, these two router, either we will use the new router, either we will purchase the new router, or if we will use these routers, the network will be shut down. So we must have a solution for this problem. So this problem can be solved by dividing the network into what? Two areas. Which one? Area 0 and area 1. So let us assume that this much network is under the area 0 and this much network is under the area 1. Now, how many routers will be there in one area? One, 2, 3, 4, 5, 6, and 7. That is means this time R2 only have to forward or receive the updates up to 7 routers only, because in this network we have only 7 routers. And if I talk about R3 also have to forward or share the information up to what? 1, 2, 3, 4, 5, 6, and 7 routers. Okay. Now the load will be reduced. How? Because the routing updates must only be forwarded in between 7 routers, and on right side also the routing updates will only be forwarded up to 7 routers. Okay. And this R1 will be the common router in between the area 0 and area 1. Well, there are 6 types of areas. How many types of areas are there? Backbone area, standard area, stub area, total stubby areas, NSSA, and totally NSSA. Okay. So, dear all, in this lecture, we are only going to discuss about these two areas, backbone and standard areas. We have a separate videos. We are going to upload a separate videos for the stub area, totally stub area, NSSA, and totally an SSA. So we will have a separate video over this. Well, if I talk about the backbone area, so backbone area is the core area of an OSPF. So all the areas must be connected to the backbone area directly or virtual link. So the backbone area is also known as what? Central hub of OSPF routing, or it is also called centralized area. Apart of this, we have standard areas. All the other areas except of area 0 is known as standard area or non-backbone area. Okay. In standard areas, all the routers maintain a complete link state database of the areas. This is your backbone area 0. The backbone area is called centralized area. So area 1 and area 2 are directly connected to area 0. It is the rule of OSPF that the area 0 must be connected directly or indirectly to all the areas. Virtually, it can be connected. Okay. So area 0 is the centralized area. That is why we have connected both of these. So what are the advantage of using OSPF areas? What is the benefit of segmentation or creating the grouping of routers? First of all, scalability. We can reduce or expand the size of network, and large network can be reduced and easily can be processed by improving our scalability. Okay, the performance will be increased because the routing updates will be forwarded within the same areas, or the routing updates will only be forwarded to the limited routers. So that will enhance the network performance. The convergence will be faster because we have divided the network into smaller areas. On the behalf of that, the convergence will be easier. By using the stub and totally stubby areas, we can filter out the LSA 5, LSA 7, and LSA 6 or LSA 3. Okay, so that is a separate part we are going to discuss in our stub area configuration. So, dear all, what are the design consideration of the OSPF areas? Well, if area size will be reduced, then it will be easy to do the fast convergence. The OSPF will easily do the what? Faster convergence, and it will minimize the routing table and the database table. These will be reduced. So larger areas can be lead to performance degradation. That it means a larger area can be responsible for the reduction of performance. And if I talk about connectivity to area 0, all the non-backbone area must be directly connected to area 0. Okay, what is the use of stub area? So use of stub area is for the regions where external routing is needed, such as smaller branches or remote site. That is means we can filter out the external areas and external routing information. When there is no external routing information needed, we can filter out that by the help of using what? Stub areas. Because that is totally depend over what? An LSA, types of LSA. So if I want to reduce the load from the external routes, I can use the stub areas. Well, we will deeply discuss about stubby areas in our upcoming classes. Till then, please hold on. Okay. Well, there are some types of router in OSPF areas. These are area border routers. So these routers are connected to more than one areas. The area border routers are the router that are common router for two or more than two areas. So these routers are connected to backbone area 0. That is means there is a common router from non-backbone, and backbone area is also called the what? The area border router. So the ABR are responsible for summarizing or redistributing the routing information between areas. So this is the common router that will have the information of both the areas. So the ASBR are responsible for importing and exporting the routing information between the OSPF and non-OSPF networks. If I talk about the ABR, so dear all, this is area border router. You can see this is a common router between area 1 and area 0. This is also area border router. This is common router between what? Area 0 and what? Area 2. Okay. If I talk about ASBR, it is a common router between what? Non-OSPF and OSPF network. Which one? Because this is the OSPF network and this one is the non-OSPF network. So it will It is the router that is responsible to share the information in between what? Two different protocol like OSPF to BGP, OSPF to EIGRP. So dear all, this is the configuration of the OSPF. Enable configuring terminal router OSPF1, then define the network. This is the wildcard mask on which already have created the videos and area 0. Any area can be taken here. If you want to check the database table, there is a command show IP OSPF database. If you want to check what? ASBR summary, go to the command show IP OSPF database summary. Cost of the interface, so the command will be show IP OSPF interface brief. The best cost for reaching the border router from internal is show IP OSPF border routers. And this is the same command that is used to check the border routers. If you want to forward the type 7 LSA to NSSA external, so the command will be show IP OSPF database NSSA external. If you want to check the type 7 LSA, that can be this command will be used. Okay. If I talk about the external route information in OSPF, put a command show IP route OSPF. So these are the show command in OSPF. If you want to check the external database, so put a command show IP OSPF database external. And if you want to check which one is the ASBR, so there's a command show IP OSPF database ASBR summary. Let's go to our GNS3 on which we will do the practical over this one. Okay, first of all, we are going to configure the OSPF on this network. After that, we are going to check which one is ABR, which one is ASBR, and so on. Okay, so let's go to first of all router number 3, router number 2, and router number 1. Step by step, we are going to configure these. Okay, so dear all, we are going to do the configuration from R1 to R7. Let's go to R2. First of all, configure the OSPF. How we can do router OSPF1? Okay. Network 192.168.11.0 0.0.0.255 area 0, because 11.2 is a part of what? Area 0. So first of all, we are going to advertise this network, then step by step we are going to advertise other networks. Okay. So in this we have just configured what? Area 0. Okay. Now let's go to R2 and do the same. Router OSPF1, router OSPF1, network 192.168.11.0 0.0.0.255 area 0. Okay. So we have just advertised this network on this side also and this side. Okay. Now we are going to advertise this network on this router. Okay. Let's go to the router. Okay. And put a command network 192.168.10.0 0.0.0.255 area 0. Okay. Let's go to R3 and we'll also do the same. Router OSPF 1 network 192.168.10.0 0.0.0.255 area 0. Okay. So we have just configured the area 0 on these three routers. After that, let's configure the area 2. For that, we have to go to R3 first of all and advertise the network. Router OSPF 1 network 192.168.14.0 0.0.0.255 area 2. Which area is this? Area 2. Let me mention the area also. This one is area 0. This one is area 2. This one is area 1. Okay, we are going to configure this first. So let's go back to the router number 3 and advertise this network. So we have just advertised this network on this router. Now let's going to advertise this network on this router. Then again we will advertise this network on both sides. So first of all, let's go to R6 and we'll do the same. Router OSPF 1 network 192.168.14.0.0.0.255 area 2. Okay. Now let's advertise 15.0 network 192.168.15.0 and 0.0.0.255 area 2. Okay. Let's do the same on router number 7, router OSPF 1 network 192.168.15.2 and then wildcard mask 0.0.0.255 area 2. Okay. This is how we can do the configuration. Now let's do the configuration for area 1 also. So R1, R5 and R4 are the part of what? This one. So first of all, go to R1, then advertise the network 192.168.12.0 and area is 1. Okay. 192.168.13.0 and area is 1. Okay. Let's go to R5 and we'll do the same. Router OSPF1 network 192.168.12.0 0.0.0.255 area 1. Okay. Let's go to R4 and advertise the network. Which network? This network must be advertised to this side also. So router OSPF1 network 192.168.13.0 0.0.0.255 area 1. Okay. So we have just configured the OSPF on all of these routers. Okay. Whenever I will ask about the routing information to R7, it will only show the routing information up to this router. The database table, the database will only be shown by only up to area 2. It will only show the area 2 information in its database. Let's observe this. So let's go to which one? R1. Sorry, R7. So I will put a command show IP OSPF database. So it will only show the database of area 2 because after the the area configuration, the isolation will be done, or we can say the grouping will be done. Okay. If I go to R2, it will also show what? The routing information of what? Area 0 only because the grouping has been done. The database table has been reduced. How we can do that? Show IP OSPF database. It will only show the information of what? Area 0. Let's go to what? Last router R4. It will also show the information of area 1 only. The limited information will be shared. So let's go to R1 and also put a command show IP OSPF database. So it will only show the database of what, which one? Area 1. Because R1 is the common router, so we have to go to R7. In R7 and R4, we will only have the area information. Whenever I will go to R3 or R1, so these are the common routers. So R1 will have the information of multiple networks. So R1 will have the information of what? Entire network of area 0 and area 1 because this is a common router. So here you can say there is a big table in which area 0 is here, area 1 is here, and two areas are configured here, or two areas are in the database table of R1 because this is a common router. Let's go to R3. We will also, and when I will put the command show IP OSPF database, so it will answer me that we have two area information, area 0 as well as what, area 2, because this is a common router, so it will have a big table of area 2 and area 0. Okay, now if there was a command show IP OSPF border router, show IP OSPF database, show IP OSPF border router. By this command we can check which one is our nearest border router. Okay, so let's observe this also practically. So I will go to which one, R2, and will put a command show IP OSPF, show IP OSPF border router. So it will answer me that there are two routers, 192.168.13.1 and 14.1. This router is known as 192.168.13.1 and this router is known as 14.1 because the routers are known with their router ID. So the router ID for this router is what? 192.168.14.1. That is why it is showing 14.1 in the show command, 192.168.13.1. So these are the router IDs. In the OSPF, all the processing will be done on the behalf of what? Router ID. That is why in that case that is showing 192.168.13.1 and 14.1. If I will go to R7, it will also show me the same details. Show IP OSPF border router. So it will answer me 14.1. This is the nearest border router to what? This routers. So by this command, we can check which one is our border router. Okay. So dear all, that's all for today. And please subscribe my channel and have a nice day.